Hi students, today in this lecture we are going to study about sets. Now sets form a very important chapter of quantitative aptitude. So in this lecture we are going to discuss about what are sets, what are the different types of sets, some of the very important operations that are performed in sets. Also we will study about the union, the intersection and difference of sets, and finally through some very interesting problems we are going to understand all these concepts more clearly. So let's quickly begin this lecture. So let us first define what do we mean by the word sets. A set is a well-defined collection of objects. The objects are called the elements of a set. So what is a set? It is a well-defined collection of objects. So if we have a group of objects or a collection of objects, then we call it as a set. And these objects are called as the elements of this set. Now these elements could be anything. They could be people, letters, objects and so on. Generally, a set is denoted by a capital letter and the elements of the set are denoted by small letters. So, whenever we are to denote a set, then we denote the set by a capital letter. And whenever we are to denote the elements of the set, then we denote them by small letters. So what we can say, a set is a collection of objects and these objects are known as the elements of set. Now, let's take different examples of sets. This is a set of cups. You see there are so many different cups, and so this comprises of a set of cups. Similarly, this denotes a set of apples and this denotes a set of numbers. So you can have set of so many things. Either you can have a set of cups, you can have a set of apples, or you can even have a set of numbers. So simply set is a collection of objects. These objects could be people, these objects could be actual things, or these could even be numbers. So set simply denotes a collection of objects or a group of objects. Now let us say that we have a set X. So this is a set X in which we have got X as an element. So X is the element of set X. We have seen that the object contained in a set is known as the element. So all the objects that are within this particular set are known as the elements of this set X. So it is denoted by X is an element of X. So small x, which is an element of capital X, this denotes that X is contained in this set. This is a mathematical notation of denoting that small x is an element of the set X. Let us take another object. Let us say it is Y. But we clearly see that this is not contained in this particular set. So Y is not an element of X because this is not contained in the set X. Now how to denote that? Y is not an element of X. So this is a mathematical notation which represents that Y is not an element of the set X. Y is not contained in the set X. Let's take an example. N is a set of natural numbers. So 1, 2, 3, 4 and so on represents a set of natural numbers and this is denoted by N. So N represents a set of natural numbers and the elements of this set would be 1, 2, 3, 4, 5, 6 and so on. A set of integers on the number line would be, all these are a set of integers that are contained on the number line. So this represents a set of integers on the number line. Similarly, if we want to represent set of vowels, then the elements would be A, E, I, O, U. So X represents a set of vowels, the elements of which are A, E, I, O, U. So these are some of the examples of sets. Now these sets could have elements as people, numbers, even objects. Now the representation is very important. How to represent a set in mathematics? For that we have got two such methods. The first is the roster method, or which is also known as a tabular method. The other one is the set builder method. So there are two methods of representing any set in mathematics. The first is the roster method, or which is also known as a tabular method, and the second one is the set builder method. One by one, let's understand these two methods of representation. The first is the roster method or the tabular method. Here we write all the elements within the braces and each element separated by a comma. We write all the elements within the brackets and each of these elements is separated by a comma. For example, a set of all the prime numbers less than 20 is represented by the set S, braces, 2, 3, 5, 7, 11, 13, 17 and 19. Now remember that these all are prime numbers which are less than 20, and each of these element is separated by a comma, and all these are also contained within the braces. So this represents a set of prime numbers less than 20, and this is represented in the roster method. So in the roster method, what we do is we contain all these elements within the braces, and each of these elements is separated by a comma. This is also known as the tabular method. The next is the set builder method. Here a set is defined by stating a property which is satisfied by all the elements of that set X. Now in this particular method, we do not write all the elements. Instead of that, what we do is we write the common property that relates to all these elements. For example, a set of all natural numbers can be written in the set builder form as X, then a vertical line. X is a natural number. So this portion represents the property exhibited by all the elements of this particular set. So here X is a natural number, so this is a property that is exhibited by all the elements contained in the set N. So this is written in the set builder form. In the roster method, it would be written as braces 1, 2, 3, 4, 5, 6 and so on. So the basic difference between the roster method and the set builder method is that in the roster method we write all the elements, but in the set builder method we do not write the elements. What we do is we state the property that relates to each and every element of the set. So any of these two ways could be used to represent a set. So any of these two methods could be used to represent any set. Now we are going to study various kinds of sets. The first is the universal set. What is a universal set? The set containing all the elements under consideration is a universal set, and it is denoted by U. So capital U represents a universal set. A universal set may have many subsets. All the elements of the subset should be in the universal set. Now, what is a universal set? Universal set is a set that contains all the elements which are under consideration. So a universal set has all the elements that we are actually interested in consideration, and it is denoted by U. Now, this universal set may have many subsets, and all the elements of this subset should be in the universal set. So that is why the name comes universal. Universal contains all the elements. So there could be various subsets of universal sets. Let's try to understand this. The universal set of alphabets is U, which is represented in the tabular form as A, B, C and so on up to X, Y, Z. So this represents all the alphabets. So U, which is a universal set of all the English alphabets, is this. Now, if we have another set which is a set of vowels, then that would be X equal to A, E, I, O, U. And now we clearly see that X is a subset of U. Subset of U would mean that all the elements of X are contained in this universal set U. So U is a set containing all the elements which are under consideration. Here the elements which are under consideration are the alphabets. Also we have a set X which is a subset of U. That is, all the elements of X are contained in the set U. The next is complementary set. What is a complementary set? In case a set does not contain all the elements of the universal set and another set has the missing elements, then that set is called as a complementary set. So let us say that we have got a universal set. Let us say that we have another set A. A has got to be a subset of U, but it is not necessary that A would contain all the elements of the universal set. It might be possible that some of the elements are left out. So another set which contains all the elements which are left out is known as the complementary set of set A. So for a set A, its complementary is denoted by A, C or A dash. So this represents a complementary set of set A. Just remember, for a complementary set there has to be an existing set as well. So for A dash to be defined, there has to be a set A. Let's take an example. Let us say that the universal set is 1, 2, 3, 4, 5, 6, 7, 8 and 9. And let us say that we have got another set A such that the elements of which are 1, 2, 3, 4, 5, 6, 7. Now the complement of this set A would be 8, 9. Clearly the elements 8 and 9 are missing in this set A, but they are contained in the universal set. So the set containing all the elements which are not contained in the set A would be the complementary set of A. So the complementary set here is 8, 9. Let us say that this represents the universal set U. Let us say that this region represents the set A. So now this entire region which is inside U but outside A is this region, and this region is nothing but the complementary set of A. So the complement of A would be this very entire region. There's one more thing you can see here, that A plus A complement is equal to U. So if we add the elements of A plus the elements of complementary set of A, then we get the universal set U. I hope you have understood what is complementary set. Now what is a finite set? A set is finite if it consists of a finite number of elements. So if the number of elements contained in a particular set is finite, finite means that which could be counted, then it is known as a finite set. Example could be a set of vowels A, E, I, O, U. Definitely we can count the number of elements contained in this particular set. So A, E, I, O, U, there are 5 elements in this set, and so it is a finite set. So a finite set is a set that consists of a finite number of elements, or the number of elements can be counted in a finite set. Let's see the definition of infinite set. Now infinite set is a set which consists of an infinite number of elements. So we cannot count the number of elements contained in an infinite set. Example could be a set of natural numbers 1, 2, 3, 4 and so on. Here the number of elements are infinite, and so this is an infinite set. What is an empty set? Empty set is also known as a null set. A set which contains no elements is called an empty set. It can be written as this way. So this is a mathematical notation of empty set. So if we have got a set and in which there are no elements, then such a set would be known as an empty set. The next is equal sets. Two sets with exactly the same elements are equal sets. So if we got two sets A and B and such that they have the same elements and the same number of elements, then such two sets are known as equal sets. So let us say that we have got a set A which has the elements 1, 2, 3, and we have another set B which has the elements 3 to 1. So what do you see here? You see that all the elements are the same. 1 is contained in A and B, 2 is contained in A and B, and 3 is also contained in A and B. Also the number of elements in both these sets is equal to 3. So these two sets A and B are equal sets. So for two sets to be equal, they should have exactly the same elements. Now let's understand what are disjoint sets. When two sets have no common elements, they are called disjoint sets. So let us say that we have got two sets. Now if these two sets do not have a common element, that is an element which is contained in both these sets, then such two sets are known as disjoint sets. For example, let us say that we have this as a universal set and we have two sets A and B. Here we see that A has the elements 1, 2, 3, 4 and B has the elements 5, 6, 7 and 8. Here we clearly see that these two sets have no common element. None of the elements is common in both these sets. So these two sets are disjoint sets. So for two sets to be disjoint, the property is that they should not have a common element. No two elements in these sets must be the same. And so this is the property of disjoint sets. Now there's a concept which is the cardinal number. What do we mean by cardinal number? The number of elements in a set is called as the cardinal number or the order of the set. So cardinal number is also known as order of the set, and it is nothing but the number of elements in a particular set. Let us say that we have got a set which is 1, 3, 5, 7, 9 and 11. Now how many elements does this set have? 1, 2, 3, 4, 5, 6. So it has got 6 elements. The number of elements in this set is equal to 6, and so what we can say that the order of this set is equal to 6, which is also the cardinal number and which is equal to 6. So in this set there are 6 elements, and so the cardinal number of this set is equal to 6. Thus the number of elements in a particular set is called as a cardinal number or the order of the set. Now let's see what is a subset. A set X is a subset of another set Y if every element of X belongs to the set Y. So if we have got two sets X and Y, if I say that every element of the set X belongs to the set Y, that is every element of X is also contained in the set Y, then X is the subset of Y. It is denoted as this way. This represents that X is a subset of Y. Let us say that we have got a set C such that the elements are A, B, C, D, E, I, O, U, Z. So these are the elements of the set C. Let us say that we have a set A which has the elements P, C, E, I, and let us say that we have another set P which has the elements A, C, E, P. Now, is A a subset of C, and is P also a subset of C? Let's try to find that. Set A has the elements P, C, E, I. Now clearly all these elements are also contained in this particular set. So yes, A is a subset of set C. Let's try to find out for B. A is contained in this set, C is also contained in this set, E is contained in this set, but P is an element which is not in this set. So P is not a subset of set C. If X is a subset of Y, then every element of X must belong to the set Y, or every element of X must be contained in the set Y. So this is the definition of subset. Remember that every set is actually a subset of the universal set. So there are two very important concepts, and that is the union and the intersection of sets. Now what do we mean by the union of sets and what do we mean by the intersection of sets? Let's first try to understand what do we mean by union of sets. The union of two sets A and B is a set which consists of all the elements of A and all the elements of B. The processing symbol of union is U. This represents the processing symbol which represents the union of two sets. So what is a union? Union of two sets A and B is a set which consists of all the elements of A and all the elements of B. So what do we do here is we add the elements of set A and we also add the elements of set B. This combined set is known as the union of two sets A and B. But one thing to remember, that the common elements are only written once in the union of sets. Let's take an example. Let us say that we have a set A in which these are the elements. We have another set B in which we have the elements 5, 6, 7, 8 and 9. Now what is the union of A and B? This union of A and B would contain all the elements 1, 2, 3, 4, 5 from the set A and also the elements 6, 7, 8 and 9 from the set B. So this represents the union of set A and set B. Here one important thing that I have already mentioned is that the common element 5 is the element that was present both in the sets A and B, and it has been written only once. So the union of two sets A and B represents the sum of all the elements from A and B, taking into consideration the common element, and in the union it is only written once. This represents A union B. Now let's see what is intersection of two sets. The intersection of the two sets A and B is the set of common elements of A and B. It is represented this way. So this represents intersection, and so this would be called as A intersection B. So this represents A intersection B, and that is a set which contains only the common elements of A and B. Let's take the same example once again. Let us say that we have a set A in which the elements are 1, 2, 3, 4 and 5. Let us say that we have another set B in which the elements are 5, 6, 7, 8 and 9. Now in intersection what we do is we search for the common elements. Here clearly the common element is 5. So A intersection B would be a set that contains the common element which is 5. So A intersection B would be 5. This set A intersection B contains a common element 5 which is present in both these sets A and B. The next concept is the difference of two sets. The difference of sets A and B is a set of all those elements X such that X belongs to A and X does not belong to B. So what is the difference of two sets A and B? It is a set that contains all the elements X such that these elements X belong to the set A but they do not belong to the set B. It is denoted by A minus B. So this represents the difference of two sets A and B. For example, we have got a set A such that the elements are 1, 4, 7, 10, 13, and we have another set B 1, 3, 5, 7 and 9. If I want to find out A minus B, then that would be the set containing the elements 4, 10 and 13. Now how do we get this? The important criteria is that we are going to look at these elements which are contained in A such that these elements do not belong to the set B. Now 1 is an element that belongs to the set B as well. We look at 4. 4 is not contained and so it would come here. The 7 is also an element in P, so it won't be included. 10 is an element that is not in the set P, and so that would be included. And 13 is also an element that is not in set P. So A minus B would be a set 4, 10 and 13. Now if I want to find out B minus A, then again it would be a set that contains all the elements of B which do not belong to the set A. So again here 1 belongs to this set, so 1 would not be included. 3 is an element that is in B but not in A, so that would be included. Similarly 5 would be included here, and 7 would not be included because it is contained in the set A, and so 9 is the element that comes here. So 3, 5, 9 is a set which is B minus A. So the difference of two sets A and B is the set of all the elements X such that X belongs to A but do not belong to the set B.